So we looked at abstract data types, and we saw how list can be a useful way to take a step back away from directly having to work with an array, for example. And list provides us with a bunch of useful methods that we can use instead. So for example, here's some of the ArrayList methods. We can get an element, we can set an element, we can get the size of our list, we can check if it's empty, we can clear the list, we can add more things to our list, and we can remove things from our list. So for the example today, I'll be implementing a similar abstract data type called stack. So a stack is really similar to a list, except for the order in which you add things and get things from the stack is a little different. So if you notice with list, we can get things or set things at a specific index of our list. So a stack is the same, except for it has a last in, first out ordering. So rather than having these getters and setters, you would have a push method and a pop method. So the push method would add things to our stack, and then the pop method would pop off and return the most recent thing added to the stack. So an example, you could literally think of a stack as a stack of books on a table. So when you push things onto the stack, you would start stacking books on the table, and then rather than getting any book you want, when you want to get something from the stack, you call pop, and pop would start popping off the most recent books you've added to the stack. So to push things, you would stack things up, and then if you wanted something back, you would call pop, and you would take the top book off of your stack. So it maintains the last in, first out ordering. So the last thing you put on the stack is the first thing you're going to take away from the stack. So let's take a look and see what that would look like. And yeah, we also looked at another thing is generics, which was a way that we could use a list with kind of any different type we wanted. So I won't be implementing the generics part of the stack. I'll just use a stack of integers for this example. So underneath, we're going to store our stack elements in an array. So we'll go ahead and make that private, because the public methods we're going to use to interact with the stack are going to be how a user from the outside world can change the contents of the array. So we'll say private int array stack, and then we'll make the default constructor to initialize that. So public stack, and we'll say stack equals new int. So since we're working with an array, we're going to need a size. I'll go ahead and declare that as a final. So private. And I'll just set that to 100. So let's make the skeleton methods for push and pop. So public void push. So we're going to need a value in our push method, so we know what to add to the stack. And then we'll say public int pop, and that's going to return a value from what was on top of the stack. And we don't really need to pass that anything. Okay. So in order to keep track of the LIFO ordering, we're going to need to keep track of the current index. So private int. And we'll start that at 0, so we can start adding things to our array at index 0. I'll go ahead and initialize that in the constructor. Okay, so when we go to push something onto the stack, all we're going to do is say our stack array sub current index is equal to value. So it's equal to the value that gets passed in. And then we need to increment the current index so that when someone goes to push something else, it won't overwrite what's already there. Okay, so let's implement pop. So when someone goes to pop something from our stack, the current index is actually 1 ahead of what we're looking to get. So one thing we need to be careful of is someone could call pop when there's nothing in the stack. So we need to make sure that the current index isn't already 0. So if current index is less than or equal to 0, so we'll just return -1 as the default value. And let's actually declare that so we know what we're doing. Or we'll say empty equals -1. So we'll just return empty. So if the current index is already 0 or less than 0, we'll just return empty. So we'll say else current index --, and then we'll get the value equals stack and we'll go ahead and set the value at the stack to 0, and then we'll return value. So for push, we would have to check and make sure that we're not exceeding our default size. I won't do that in the demo, but you could think of a way to solve that is if you actually get to the maximum size, you could redeclare your stack array to be, let's say, twice as big as what it already is. So if someone exceeds the size, we could declare stack as a new integer array of size 200 and copy the old stack onto the new stack. So then after that we would have the old stack, and we would also have 100 new spaces that we could put integers. But yeah, like I said, I won't implement that now. So let's override the toString method so we can actually look at what's in the stack. So public string toString So we'll start at 0 and just loop through the array up to the current index and add that to the string. So we'll say value plus equals stack sub current, or we'll say sub I. And then we'll also add a comma and a space. And then at the end, I'll just put a closing square bracket. And then we'll return that string. Alright, so from here, let's make a new instance of our stack. So we'll say stack. And then let's go ahead and just print out our stack to the console. Let's see what that looks like. Alright, so we have an empty stack here. So let's push some things onto this stack. Push 1, and we'll push a couple things. Alright. So you can see our stack grew. So if we put that into a loop, let's just loop through and start pushing things onto our stack. we'll push I, and we'll print the stack every time we push. So you can see our stack's growing. Now let's pop some things. So pop. And remember, pop returns the element that was there. So we could store that into an integer or use that somehow. So, but then if we go to print the stack again, you should see our stack is shrinking. And you can see that the last element that we put on is the first element that gets popped off. So let's put that in another loop. Yeah, so we go through and push 0, 1, 2, and 3, and then we go through and pop 4 times. So you can see it shrinking in the LIFO order. So if we wanted to, we could come back to stack, and let's add a few other methods, kind of like list has. So we'll say public boolean is empty. So this will return true if our stack is empty and false otherwise. So we can check that by checking the current index. So we'll just return whether or not current index is equal to 0. So if the current index is equal to 0, we have an empty stack. If we've added things to the stack and the current index is greater than 0, then our stack is not empty. So let's go back over here and test that. So print line is empty, and then we'll call our method is empty. So here the first iteration should be true, and then after that it's not empty anymore. And then we'll print it again when we're popping. Oops. So initially it's empty, but then we start pushing, so is empty comes back as false, and then when we're popping, it remains false until there's nothing left. So another thing we can add to our ADT is, let's add a size method. So public int size. So this will just return how many elements we have in the stack currently. So all we have to do for that is return current index. So yeah, we could go through and change this to size. So now we have a nice way to get the size, and then just one more thing we could do, and you can see we could keep going and keep adding useful methods that you might want. But let's make a nice way to clear our stack in case we're done with it. So public void clear. So yeah, I mean there's a lot of different ways we could implement clear, but we can just say while current index is greater than 0, let's just call our pop method. So while there's still things, or actually let's change that even. Let's change that to while not is empty. So while the stack isn't empty, which is using the method we made last time, just keep popping elements. So this will just keep popping things until our stack is considered empty. So let's test that. So here, if we run that again, you'll see the stack. I'll change that to 10. So now we can just call stack dot clear, and then if we go ahead and print out our stack again, we should have an empty stack. Yeah, so you can see the last one after we clear, it's empty.